Hello viewers, good day to you all. You're welcome to today's class. I remain your pro guide, Aisha Wendy. The video is sponsored by Proj Connect. Today we have questions to solve from a topic which is known as isotopes. So we're going to explain isotopes, the real life applications of isotopes, and also we move on to the calculation aspect of the topic. Atoms exist in different atomic number but having the same mass number. Such type of atoms are called isotopes. And basically, not all elements which are isotopes are stable in nature. And under isotopes, there is what we call relative abundance. Relative abundance is simply the amount of each isotopes in nature. Example of an element that has isotopes is chlorine. Chlorine has two isotopes, isotope 35 and also isotope 37. That's why chlorine is written this way, isotope 35 and isotope 37. So let's talk about the format of isotope. That is how isotope looks like. Isotope exists in this way, where you have X, here you have A, you have Z here. So the A, the Z, and the X all have their meanings. The X is the element in question. A is the mass number. The mass number is the number of protons and neutrons that exist in the nucleus of an atom. So we have the A here, which is the mass number, while the Z here is the atomic number. And the atomic number defines the elements because the atomic number is the number of protons in the nucleus of an atom. So basically, this is just how isotope is written or exists. So let's talk about some of the real life applications of isotopes. Isotope is used in medical use for treatment for radioactivity. Isotope is also used in scientific research where archaeologists use it in determining the age of artificial artifacts. So these are some of the real life application of isotopes. So let's look at the calculation aspect. We have some few questions here. The first one says, determine the amount of neutrons in this isotope. We have element K, which has the mass number of 39 and atomic number of 19. So, as we have element K, here we have 39 and 19. So for us to get the number of neutrons is equal to A minus Z. And remember, we said that our A is the mass number, while the Z is the atomic number. So in this case, we have the mass number A is 39 and the atomic number Z as 19. So the number of neutrons in this case, N, is going to be the atomic, that is the mass number, minus the atomic number, just as simple as that. And the mass number here is 39 minus the atomic number, which is 19, and the neutron here gives us a value of 20. Okay, so as simple as that. So the number of neutrons in this first question here is 20. Let's move on to the next question 2, which says an isotope has 8 protons and 10 neutrons. What is the isotope? So number of protons is equals to 8 and the number of neutrons is equals to 10. I remember from my definition, I said that the number of protons is what? The number of protons in the nucleus is known as what? The atomic number. So that means this proton here is the atomic number, okay? So now they are asking us that what is the isotope? So how does this isotope exist? Or what is the format of the isotope? We need to get the atomic number, which is A. I remember I said that the atomic number is the number of protons and neutrons in the nucleus of an atom. So the number of the protons, Z, plus the neutrons, okay? So for us to get the atomic number A is going to be, that is 8 plus 10, and this gives us 18, okay? So what this means is that, as we know, this is how an isotope exists. We have isotope X, which has the mass number A and the atomic number, which is Z, right? So now let's use this X. as the element. Let's assume the element is X. So what is the mass number? So the mass number here is 18, while the atomic number is 8. So an element that has atomic number 8 and the mass number as 18 is oxygen. So that means this isotope is oxygen. Here is 8 and then 18. So the isotope is oxygen having the um, and the mass number of 18 and atomic number of 8. So basically, this is the answer. Simple and as straightforward as that. Okay. So let's move on to the last question.